Alright, what's going on, guys? Today I'm back with another video. Today I'm gonna be doing kind of like a little a video kind of similar to the last video, or a video that I did a little bit ago called "Watch Me Struggle to Do a Leetcode Question for 29 minutes and Rage Quit." So this basically just means I'm gonna be solving this question on the spot. I've never seen this question before, um, or submitted it, or I know nothing about it. I just had a friend send me this question on Discord, saying that they were doing it. So I thought I would give it a go, and just from reading it, I thought it was a good question, and I just read it maybe like a couple minutes ago. So it's just fresh in my mind. And I thought like maybe kind of walking through how I solve it, um, might give some value to some people if they are also trying to solve this question. But yeah, anyway, so let's kind of get into it. So this one's given the root of a binary tree. Imagine yourself standing on the right side of the tree. Return the values of the nodes you can see ordered from top to bottom. So, for example, you would see 1, and then like if you're standing right here, you would see 1, and then 3, and then 4. Yeah, so I'm actually gonna do this question in Java, just because I'm kind of bad at doing tree questions in Python. Yeah, but so basically, I've kind of been practicing tree questions a bit, so I'm pretty sure like I know how to do this one right away. But basically, what my initial thought is to just do like a level order traversal, okay? And just each time you do the level order traversal, check if you're at the last like element in that like level order, and if you are, add it to like an array, and then just return that array. So here we would be, okay, so there's only 1 in the first one, so we could add the 1. Here there's we would say 2, we would not add it because it's not the last one. Here we would see 3, we would add it because it's the last one. Here, and then we go to the next level, we wouldn't add anything. We wouldn't add 5, we would add 4, and then we should get this. And so yeah, so let's get into it right away. So it's been actually a minute since I've done some Java, so this might just take me a minute, but should be fine. So tree node, call this myQ, equals new, how do you, I think it's equals new, is it linked list, I believe. Just a test, just to double check that. Wait, so what are we? Oh, we're returning a list. Okay. So let me just quickly check. I'm just quickly double checking how to initialize a list. Yeah, okay. So then we'll also make a list, and in the list we will have integers. Call this we'll call this result, just so you guys kind of know, and then equals new array list. Okay, return result. Should just be empty, but no. I just gotta double check how to initialize queue. Yeah, it's just kind of been a minute, guys, so sorry about that. It's kind of awkward, but oh no, I had it right. Okay, yeah, you just need this. Yeah, I thought it was like that, but yes. Okay, nice. Okay, so then what you do, first thing you do is you go myQ dot add the root. Yes, add the root. Okay, and then we'll say well myQ that is empty. Well, my queue is not empty. Okay, bada bing. Okay, we will then say int size equals my queue dot size. Okay, and then we'll say for int I equals 0, I is less than the size I plus plus. Okay, and then we'll say tree node temp equals tree node temp equals my queue dot remove yeah, how do you enqueue? I think it's just remove. Yeah, remove. Yes, remove queue. Okay, you then say if temp dot left is not equal to null. If temp dot left is not equal to null, you then go my queue dot add temp dot left. Yeah, so this is just what I'm doing right now, guys. It's just doing a level order traversal. Okay, you then say if temp dot right is not equal to null. If temp dot right is not equal to null, my queue dot add temp dot right. Okay. I feel like that should be. I'm just gonna. This isn't that quite. I haven't quite finished kind of the condition yet. I just want to double check and make sure that I'm doing the traversal correctly. Dot print line. Let's say temp dot val. Okay. Let's run it. Okay. Okay, I guess it's actually just if temp is not equal to null. Yes, that makes sense. And so, kind of what we would expect, but bing. I'll just say actually if temp is not equal to null, oops, temp dot file. One, two, three, four. Sorry, 5, 4. Yeah. Okay, cool. So now what I will do, I'll say if temp is not equal to null. And we want I to be equal the size minus 1. So for example, the reason it's not equal to size was, well, it won't be because it only executes when I is less than size. So on this case, size is going to be equal to 2. So this will be when it's 0, and this will be when it's 1. And so that's why we need to do size minus 1. And so we get 1, 3, 4, and that's exactly what we want there. So now all we need to do is say my list. Oh, sorry, I meant result dot add temp dot val. Boom. Go ahead. And yeah, so it actually seems like that's the solution. I guess, yeah, I think that's about, yeah, so that's, yeah, definitely O of n. Solution, every node's getting visited one time for maximum of n times, n representing the nodes. And so I think that should be good to submit. Ooh, okay. Let's use this test case. Ooh, interesting. Okay. So in this case, oh, because if you were standing on the right, you would see the 2. Interesting. I feel like you could say this. Hold on. So, I'll show you guys what I'm thinking right now. So I'm thinking temp is not equal to null, or how do you do or in Python again, or Java? Or the size equals 1. So for example, if there was no 4 here, we'd want to add the 5. And that would be when the size is, question, are we putting nulls into the size? I don't think so. I think that's fine. Okay. Or the size equals 1, and temp is not equal to null. Yes, this in a bracket, no problem. No. I think the issue is temp is not equal to null. So I believe what the issue is that in this case, we are actually, so we're saying, okay, if temp, we're adding 1's left, which is null. So I think we need to change up our condition. So I think I need to change this to say if temp is not equal to null. Then we need to say so if temp is not equal to null, then we need to say if temp dot left is not equal to null. That may work. Yes. Let's go. Nice. Yeah, so basically all I did, so before in our kind of in our queue, what we were doing is we were adding in like null values into our queue. And so now we're not adding the null values. So before, like, we'd be adding 1, we'd be adding 2, 3, yada yada. Once we get to the next one, we would add 2 left, which would be null. We'd add 5, so that's why I was messing up with the size. But this is good. And you can check out the details. Beats. If we submit one more time. Yeah, so 1 millisecond. So yeah, I mean, it's an O of N solution. But yeah, anyways, hope you guys had a good day. Hope you guys had fun watching me solve this question. As I mentioned, never seen it before. And so yeah, hope it helps.